Hi, it's Naomi. I wanted to go over this problem that has to do with finding the equation of a line when given a pair of points. This is one that's in the checkpoint. If you're one of my students, it's number, or problems around number 50 on the week 6 checkpoint will be like this, where you have to find the equation of a line given 2 points. Now, when you're given this type of problem, I generally recommend kind of taking it in two big chunks. The first chunk is finding the slope of the equation with those 2 points just by using the slope formula. And then the second part is using either one of those points with the slope and plugging them into the point slope form or point slope formula in order to get an equation for the line. So those are our two kind of parts of our problem solving process that we're going to go through. So let's see. First, finding slope. So this is the slope formula. Slope equals rise over run. Of course, the difference in the two y values is going to be how much the equation rises from one point to another. And then the difference in the x values is going to be how far the equation runs from one point to another. So this is rise over run. And I'm just going to pick one point to be point 1 and another point to be point 2. I have to make sure that I'm consistent about which point is point 1 and which point is point 2. So if I wanted to call this first point point 2, I could do that. Like if both those values were positive and both these values were negative, something like that, I might want to do that. Here I'm just going to call this point 1 and this point 2, but I have to be consistent. So if this is x2, this has to be y2. If this is y1, this has to be x1. We'll have to make sure I'm consistent about what's 1 and what's 2. Okay, so plugging in, I'm going to let this point be point 2. So this will be my y2 value. It will go right here. And then y1 will be the other y value. So it's going to be minus a negative 1/3. Of course, that'll turn into a plus. My x2 is the x value of my second point. So it's 5/6. And then my x1 is the x value of my first point, so it's going to be minus 1/6. So I put all those values in there, and this is what I get. 5 minus negative 1/3 over 5/6 minus 1/6. Now, this is pretty ugly as far as expressions go because I've got these fractions over fractions, and that's just not beautiful. So I'd like to get rid of the fractions in the fraction, these little fractions. And one way I can do that is just multiply by the common denominator of all the little fractions. So here I've got 6 and 3, so my common denominator will be 6. And I'll multiply through by 6 over 6. So if I multiply by 6 over 6, that's just 1. It doesn't change the value. It's just going to change how this big fraction looks. I have to multiply everything by 6. So this will multiply by 6. It'll be 30. This will be plus 1/3 times 6. And 1/3 of 6 is 2. So it'll be 30 plus 2. On the bottom, 5/6 times 6 is just going to be 5. The 6's will go away. They'll cancel out. And then minus 1/6 of 6, and 1/6 of 6 is just 1. So I'm going to have 5 minus 1 down in the denominator. So here's my new expression here. Slope is 30 plus 2 over 5 minus 1. And then I just add or subtract those. And I'd get slope is 32 over 4, or 32 divided by 4, and that would give me slope equals 8. So now I have my slope. I'm done with my first big chunk of the problem. So I've got the slope, I've got a point. I'm going to go ahead and use the point slope formula here. Y minus y naught equals slope times x minus x naught. I'm going to use the second point since it only has one fraction. It'll be a little easier. And 8 for my slope, and just substitute in. So y naught was 5, x naught was 5/6, the slope was 8. Then I distribute that 8. 8 times x is 8x. 8 times 5/6 is 46. I would add 5 to both sides to get that y by itself. And then, let's see, I'd find a common, this could be reduced, find a common denominator. Reduce this, it's 20/3. Write 5 as thirds, it's 15/3. And I combine my like terms. Negative 20 plus 15 is negative 5. So I'm going to end up with negative 5/3 there. And that's it. This is my final equation through that point, those points. Bye.